Okay, so this is going to be the next video in the series on device context structure. Okay, and so we're going to start with the graphics mode section of the device context structure. Okay, so the first one we're going to cover is the background. Okay, so what the background does for you, it gives you a couple options that you can specify when drawing something on the client area, how the background is going to be applied there. So when you call the function set bk mode, which stands for set background mode, you specify the handle to device context, and then you can specify either two options, either opaque or transparent. So what this does for you, as you can notice here, I have a small section there of the client area. So when we wrote hello world, okay, when we specified set background mode as opaque, the system used the value that we specified in the set bk color function to use as the background color for that area that we wrote the hello world. Okay, and when we use specify transparent in the set bk mode function, as when it says transparent there, there was no background drawn. Okay, so just simply wrote hello world, and the background was the client background was used as the background for the hello world. Okay, so if you want to have a different background, then you have to, by default is I think specified set bk mode is by default opaque, and then you have to just call set bk color to specify the color that you want for that background there. All right, so that's the first option that you get in graphics mode. So that's what it does for you, background. The second option that we're going to go is going to look at the drawing option. Okay, the drawing option there here is basically designed for raster operations. Okay, so this drawing option here will specify, you basically tell the device, the operating system, how to combine the pixels from the background of the client area with the pixels of the brush or the pen or whatever is using to draw something into your client area. Okay, so this graphics mode tells the system how the foreground colors are to be combined basically with the background colors. Basically how to combine the existing pixel color that is on the screen with the color of the pen or brush when drawing the new image. Okay, so when you call set ROP, so set raster operation 2, okay, so it's a new version of the function, I think. So ROP stands for raster operation. You specify the device context that you want to set to, and then you specify the type of operation you want to specify. So R2 underscore copy, what it means is basically it's going to copy the it's going to use the pixels going to be set to the color of the pen. So in our case, we have a green pen specified. Okay, so it's going to draw the line here as a green line. Okay, so when like we said, we call set raster operation to device context pen. Then we can call select object HDC and H green pen. Okay, let's assume we have created a green pen, and then we call line to draw the line. Okay, so that will result in this section here. Okay, it's going to result in drawing of the green line. Oh, okay, now let's look at the next operation here. There are lots of operations on that for that function that you can specify. But let's look at a little bit more complex example when we set ROP, which is last operation to the device context, and then R2 underscore X or pen. So with this option, the pixel is the combination of colors in the pen and the screen, but not both. So what it means is that here I have on the side here an example for you. So the background, okay, the background color is basically specified here, okay, as in the RGB mode, okay, in a binary format. The actual color of the pen is green, so we have here And then the way we are combining it is doing an XOR operation. So that means if there is a 1 and a 0, then 1 goes in. If there is a 0 and a 0, then 0 goes in. But if there is a 1 and a 1, then 0 goes in. So this will be the combination at the bottom, which is going to give us a purple color in the end. Okay. So basically, yeah. So you're using the set ROP function to specify the drawing, how the pixels already on the screen or in the client area are to be combined with the color value of the pen on the or the brush that's being that's doing the drawing operation there for you. Okay, so that's the drawing part here. It's fairly simple. Okay, nothing too complex. Now let's look at the mapping mode, because the mapping mode can be a little bit confusing for some people. Okay, so there are a bunch of mapping mode options. Most of those mapping mode options are already predefined for you, so you don't have to do much. You just specify the mapping mode, and the system will do the correct translation for you. There are two of those options that you have a little bit more advanced, more complex. So the first one is the ionotropic option, and then the second one is the anisotropic. So let me go over with the basic one. That by default, the set map mode is set to text, so which stands for mapping mode text. So what this mapping mode is that each logical unit is mapped to one device pixel. Okay, positive X is to the right and positive Y is down. So each pixel on the screen represents basically equivalent to one pixel in logical units. Okay, that's the translation. The other option, which are more complex here. So let me do the anisotropic one for you. So for that one, you have to set the window extent and the viewport extents. And the order is in some of them is important. So you set the window extent first, and then you set the viewport extent afterwards. So the way you should think of it as those extents, let me go here to this. Where do you go here? Let me go this way. The way you think of it is this way. Let's say you have a plane, like an area in memory somewhere, and the computer draws an object for you in that memory. So in this coordinate space, you have x in the x direction, y is positive in the y direction, okay? And we have this, like a polygon in there. So when we call set window extent function, okay, we specify 5 and 3 in this example. So I'm specifying 5 extents in the x direction and 3 extent units in the y direction. And there is no specific value for that. So what it means is that there are not centimeters, not millimeters, not pixels. You just specify the extent, just a pure number. So the way you think of it is like if you have this plane here, basic one, you're telling the system that this plane on the window extent is equivalent to 5 units. So 1, 2, 3, 4, 5 in x direction and 3 units in the y direction. And what the system is going to need this information to compute the scaling factor for us. So that's when it draws. So that's the first step. The next step is to set the viewport extent. The viewport extent is not the viewport dimensions, okay, just an extent. So the way you think of it is, again, think of it as lines, as sections, as dividing the plane into sections, okay? So in our case here, we're setting the viewport extent to 10 section in the x direction and 6 section in the y direction. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so as a result of that, the scaling factor is set in the x direction is set to 2. So it has to double, right? So we go 10 divided by 5. Okay, so set viewport extent divided by set window extent. So we go 10 divided by 5, which is equal to 2. So that means that any objects that we have originally drawn here, okay, in the end, when they're going to be scaled up by 2, so they're going to be double in size when it comes to the end display. And then what happens? We have the viewport. Like if you don't change the viewport, then the viewport itself is usually the client area of your window. So then the system will map that object from your memory, like from the computer memory itself, onto your window, right? On a scaled basis. Like it will scale twice the size. So it was in memory, it was like 1. It's going to be double the size when it's drawn onto your window, into the actual viewport. So the best way to kind of better clarify this for you, let me just give you an example to demonstrate this here. So this is our window here. Okay, so very important. We have window extent 10 by 10 and viewport extent 10 by 10. So what we have here, if we go back to our operation here, okay, so we have, so this is set here, set window extent 10 by 10. So this will be 10 in X direction and 10 down. And the viewport extent is 10 X direction, 10 down. So what it means is that we have a scaling factor in X direction of 1 and scaling factor in X direction of 1, in Y direction of 1. Okay, so that's what we have here. Now, keep in mind that the client, let me just maximize this to make it easier here. Keep in mind that the client area is 1366 by 685. So that's the client area for this here. So this is the size of the client area. Okay, so this is not the size of the window because window has the title menu. So this is, we just get into the device context for the client area here. I mean, sorry, for the clipping region for the client area. So the client area is 1366 by 586, and the scaling factor is 1. So we draw 1-to-1 scaling here. Okay. Now let me just, then we go here and we're going to change this viewport extent to 15. Okay. Do you see how it changed? It went larger. So what we did here, if we go back to our drawing here, we still have this at 10 here. We have this plane to divide into 10 sections, but in the viewport extent, this plane is divided into 15 sections. So we scaled by time 1.5. We scaled it up. And things went, but keep in mind that the client area did not change. That means the viewport itself did not change. And the height also of the client area did not change. So the width and height still the same. But the scaling changed because the viewport went to 15 and the window remained at 10. So let's go to 20 on the viewport and then to 30. So as you can see, anything that does not fit in the client, in the viewport itself, is being basically cut from the viewport. Okay, so it's not going to show. Now we can do this on view extend. So what we have when we go window extend, we go to 15. So and yeah, so here's the scaling factor is 3 right now. So everything that was drawn originally went 3 times the size now. Now when we extend to, when we go down to 15, so we're scaling the factor to 2. So now it's twice the size what was originally drawn. And when we go extend, window extend to 20, it's 1.5 now. And when we go to extend window to 30, so 30 and 30 is to 1. So basically, Windows operating system needs to know those extents for scaling purposes only. Okay, so it's, other than that, you don't need to set them. So that's why when you call some of those functions there, with some of those options, when you set mapping mode, some of them have those extents already predefined for you, so you don't change them. But these two options allow you to change those extents. So that way you can determine how the actual drawing is being mapped onto your client area, like what size. All right, so that's kind of the mapping mode here. That's the main thing. So you have to specify window extent and specify viewport extent for those two mapping mode, isotropic and anisotropic. And the order that you specify those extents is important. Okay, so you specify window extent first and then viewport extent later. Okay. Now, so that's the thing here. Let's go look here at the next item. Yeah, this thing can be a little bit confusing, so it's kind of good, to practice. But the main thing to remember here is the window extent and viewport extent I just strictly used for scaling purposes by Windows. Okay, that's all it's used for. Now let's go to the next section. Where do you go here? Let me just cover here. No, let me just cover. This is poly. Okay, so this one here. This will go the. Okay, let's go. This is covered. Cover here. No, this is not going to come back here later. The cover here. Okay, let's look at the polygon fill here. The next thing, the polygon fill, what it does for us is basically determines how the objects that are more complex are filled in. So when you call the set polyfill mode and we specify alternate, what it does, it basically fills in the center area of the polygon. So if this is our polygon, we specify points. We have, let's say, 10 points. We specify these are the points that make up the whole polygon. And then we call in polygon ADC M, we specify points and how many points there are. This is the function. So what we'll do, if it says alternate, it's going to basically hollow out the area. So it's going to treat it like a donut type of thing, right? While in a winding option, no such thing will take effect, right? So this is polygon fill, mainly used for drawing complex polygons that and so it's not often used like if you write code or whatever, like unless you're writing some complex code, this is generally not going to leave it as default for the most anyways. Okay, and I think the default option is winding option, I believe, but I'm not sure about that. But that's the main the polygon fill aspect of that. Okay, so the next item in the graphics mode is stretching, which basically determines how bitmaps are stretched when they are mapped onto the into the final image. I'm not going to cover this in this video, so we're going to cover that when I do covering more on the bitmaps in the next video. Then I will go into details there for you. Okay, and then let's see here. Okay, so let's look at the pen. The pen is just a refresher from the previous. I believe I think I covered that before. If not, then this is basically much like brush. So you create a pen. Okay, you specify create pen function. You specify what type of pen it is, the color, the width. What this is going to do in memory is going to create basically like a structure where it's going to save this information for you. In return, it's going to update the handle table. It's going to give you a handle. It's going to put the handle into which is going to link to the memory address where the pen structure information is saved, and it's going to return that. It's going to return that back to you, the handle back to you here, which then you can basically when you call select object ADC HPen green pen, you can then load that green pen into the DC structure. So whenever you do some line drawing, it's going to use that color for you. Okay, so that's the pen here. Okay, so let's look the next time. Let's look at the brush. I think I covered that before. The brush, I think brush was covered before. Actually, not. Okay, let's do here. So here you go. You have a brush here. So just so brush is similar to pen. Okay, so you can call create solid brush. You specify the RGB, which is the macro that specifies the color of the brush. The operating system will basically save this information into a structure is going to update the brush handle table for you. It's going to give you a handle back. And then you can call select object with that handle that was returned from the create solid brush function. And then you can update that will basically specify the device context that you want to update, the device context that you want to update. And then you specify the brush that you want to put in there. So that way, when you do some drawing on the client area, it's going to use that brush for you. Okay, so the next aspect is the bitmap. Okay, which is the image. So I'm gonna touch basically on the bitmaps here in this video, and then we're gonna more details gonna go into the third video on the device context. But before we do that, we need to step back a little bit and do some refresher here. So let's, as you know, when you write code, you have to specify two things first. You have to specify window class, and then you have to call create window function. So when you specify window class, you fill in some details for that window class, like the icon, the cursor, main window procedure, the background brush. Okay, you know, the menu, like if there's a menu, you specify the menu. And then you register, you call register class. And so what the register class will do is basically gonna think of it as basically copying the information to the operating system. So the operating system is gonna save that class for you with those variables, okay, for future use. Then when you go to create window, when you call create window function, what will happen, Windows will also save some of that information from the create window function, and then it's gonna use that information from the window class and the from the window class structure that you registered, and the window class and the window create window function to create your window for you. So you're gonna have the menu here, the icon, the background color here for the brush, the the cursor here, the width, the height, the location. Okay, that's all is going to be used by Windows to draw the window. But the way to think of it, that you should think of it, that the way Windows does that creates windows, the best way to think of it is this way. When you call create window function, the operating system will allocate enough memory for a bitmap that has the same width and height as you specified in the create window function. So basically, Windows basically creating a bitmap image for you in its memory, okay, based on the and then based on the specification that you gave in the create window function. Then the operating system will use that space to draw your window based on the specification that you provided in the window class structure and create window function. So you think of it is this way: you have a memory address. Yeah, Windows allocates some memory. The memory has been allocated. It's going to be used to store color values for your window. So, for example, the icon, let's say here, has an orange color. The border has gray color. The background pixels here have white color. So what this? So the operating system just created a bitmap memory of your window and filled in the colors for that window. Then the memory address is then the bitmap handle table is going to be updated. So you're going to be allocated a handle that's going to link to that memory address. And also, what will happen, that bitmap is also going to be linked to the window handle. So that's what, like, again, this number may be 100% accurate, but you need to think of it this way. So it's going to be easier to understand the logic behind it. So they are linked. So the window handle is linked to your bitmap image for your window. Okay. So basically the memory area where your bitmap image is saved for your window, you can retrieve that based on the handle to your window. All right. So yeah, so you have the header window, border, file menu. So let's go back here. Let's here. So this is what we're gonna need here. Okay, so here's what happens when you call get DC, so which get device context, you specify the window that you want the device context for. Okay, so the window will give you one of the available device contexts. It's going to allocate to you, give you the handle to it, and it's going to fill in some data, like the bitmap, the default pen, brush, font, all those will be filled in. So the bitmap in our case is going to be filled in with our window bitmap memory address that we just, when we call the create window function, we're going to that handle, that window handle is going to be used to look up the bitmap that associated with that window. Okay, so the way you think of it is that we have a bitmap handle table here that points to the memory address in the computer memory where our bitmap for our window is saved. Then the handle value, when we specify H window, we're going to look up which bitmap handle belongs to, which window belongs to which bitmap handle, and then it's going to pull that bitmap handle into the, it's going to basically save that in the H bitmap in a device context structure. Okay, so that's how you, so this is going to be our basically our drawing surface. So anything that we draw in there is going to go into that bitmap. So when we go here, the second step also, it's called, we're going to look over the region. So what the region does, the region is basically a structure that is a rectangle that specifies where we can draw in. So in our case, because we're retrieving get device handle, the region is going to be set to the client area of our window. Okay, so like the region is going to be, let's say our window is client area is 00 with by 11. So it's going to be left 0, right 11, top 0, bottom 11. So the client area is going to be our region, and the operating system is going to load that region and the handle to the region into the device context structure. What the region does is basically restricts where windows or our calls to draw something can be drawn in. So if we have here, if you want to draw, let's say, here's the situation. We want to draw a line. So we create solid brush. Okay, so with the green brush, this new green brush, then we go select object here, select object. We're selecting the green brush into the device context structure. Then we call move to HDC2. So we go to the 2 area. So let's say here. Okay, so that's from 00 to 2. Okay, so if we go here, and then we draw a line 266. Okay, because that 2 and 66 that is within the region, it allows us to draw in there. If it was outside the region, anything that would be lying outside the clipping region that was specified outside our client area, that would be no longer drawn. It will be deleted. So you will have partial line, but not a full line there. Okay. So basically, yeah. So you have the memory address. Think of it, this is our bitmap, and then basically the when you call line 2, the system will fill in our bitmap address here, right? We're gonna fill in the color for each pixel. So basically, the way to think of it, the bitmap, when you retrieve the device context structure, the bitmap in that device context structure represents the drawing surface for your window. So that's where you can draw stuff in the memory locations, right? That's when you call, let's say, drawing a bitmap or drawing like a line or anything. The operating system will draw into the bitmap first, and then it's going to copy that bitmap into your another bitmap, like for example, the desktop window is a bitmap, basically a window, right? The main desktop window is a bitmap. So it's going to copy into there, and then it's going to copy the information to the graphics hardware where it's going to display on your screen. So if you think of it that way, it's going to make it easier for you to think how the device context interacts with the operating system. Okay, so let me see here. Did I miss anything here? That's good. That's good. Here, I addressed that issue. So yeah, so the main thing to take out of this is that think of it as the bitmap in the device context being like a drawing panel or surface for your window. That's the main thing, and that the scaling if you need to scale anything, you need to specify even in the mapping mode, you have to specify the window extents. All right. So yeah, it's gonna be a little bit short video here. I'm gonna end it at this point, and I will cover in the next video. I will cover more details about the bitmap and the other whatever I left out from this structure. Okay. Thank you.